Hello everyone, I hope you are doing well. In this video, we are going to talk about scalar product and we'll see what it is, how to denote it, and how to calculate it because I was uploading some of the videos about EMT and I have to introduce you people about vectors, and there we were talking about scalar product, and I thought that there is a need to upload a video that is dedicated to finding out the scalar products, and separately I should upload a video on the vector product as well, that how to calculate them because they are really important. And in derivations, for example, you'll see them multiple times. So yeah, that is how we felt need of this video. So let's quickly get started. A scalar product, as the name suggests, this product results a scalar quantity, but it starts with a vector quantity, means we have two vectors, only two vectors. Scalar product basically is a double product, okay, of two vectors. For more than two vectors, they are named as, for example, scalar triple product, vector triple product. It depends the number of vectors involved. So scalar product is basically the product of two vectors, and let's say we have a vector A and B, and we have these two vectors, and the scalar product of vector A and B is written as, it is written as A vector. Okay, vector means arrow over the symbol to show that it is a vector quantity, dot sign, then we have the other vector. Okay, this is the representation of scalar product of two vectors A and B, okay, with a dot in between them. That dot shows the operation of scalar product. Okay, this is that operator. This operator is represented by the dot sign between the two vectors. Okay, this is the way to denote a scalar product. For example, if you want to find out the scalar product of C and D vector, then how you will write it? It's like C dot D. And in scalar product, the order of vector doesn't matter. It means if we want to find out the scalar product of C and D, and if you are confused whether to write C first or D first, that doesn't matter, because in scalar product, order doesn't matter. Both of them will give you the same result. Okay, but in vector product, order matters. So, but in case of scalar, you don't have to be, worry about it. So yeah, this is the initial details about the scalar product, that how to denote them. Okay, and their commutative property, as we can see. Okay, now next is, let's say we have two vectors, okay, and we want to calculate the scalar product. Then how we are supposed to do that? There are two ways to do this. The first is, let's say we have a vector A and a vector B, and let's say the angle between them is theta. Okay, let's say we have this is vector A and this is vector B, and the angle between them is theta. How to calculate the scalar product between A and B in numerical form? Okay, this is the formula. A dot B is equals to A, which is the magnitude of vector A, into B, which is the magnitude of vector B. And since magnitudes are scalars, that is why there is no need to write dot or cross or something like that. There is no need to do that. And into cos of theta. Okay, cosine of theta. Theta is the angle between A and B. So this is the simplest way to calculate the dot product. Simply, I said dot because there is another name for scalar product, which is dot product, because dot is used to represent them. That is why there are two names. So both of these names are used for the similar thing. And this is the first, okay, way. If you are given with a vector A and B, you can easily calculate, and the angle is given as well. Okay, sometimes the angle is not given. What we need to do in that case, or what could be another method to calculate it. So let's dive into the second method. For example, we have vector A, whose vector again, let's say we have a vector A, okay, and its x component, this is its x component. X is written in the subscript, okay, it's not actually a thing, it's just written in the subscript to show that it's the x component. I hat, which shows the direction, plus ay j hat plus az k hat. Okay, I, j and k hat are actually the basic directional vectors. Okay, so all the direction just reduce into I, j and k. Okay, this notation, this is just a hidden notation. When you put the values, you will get the result ultimately in the form of I, j and k. So don't get confused when you see these forms. So let's say now we have b vector, that is bx I hat plus by j hat plus bz k hat. Okay, so how to calculate the dot product between these two vectors? So this is like a dot b. The first step is to write both of these vectors values with dot in between them. Okay, and don't forget to use brackets. Ax I hat plus ay j hat plus az k hat. Then we have b x I hat plus by j hat plus bz k hat. Okay, I have just wrote them. Now what will be its dot product, and this is how you calculate it. You can see this is I hat and this is I hat. Similar unit vector quantities, just simply their magnitudes are multiplied with each other. Okay, so we have ax bx separated by a plus sign. Okay, I hat and their magnitudes are simply multiplied with each other, then plus sign, then j hat magnitudes are multiplied with each other, which is ay here and this is by here, so it's ay by here plus az bz bz. So this is the final product. So a dot b is equals to ax, their x components are multiplied with each other, plus their y component are multiplied with each other, then plus sign, their z component are multiplied with each other. So if they doesn't contain any variable and they only result into a number, for example, let's say you multiply and you get 3 for them, 4 for them and 5 for them, you'll simply add them up to get the final result. Okay, let's have an example. Let's say we have a vector to be equals to 3i hat plus 4j hat, let's say, and b vector is equals to 2i hat plus 3j hat plus 4k hat. So what we want to find out is a dot b. We can simply calculate them in place of here, since k hat vector is not there, it means it's 0, so like that. So a dot b will be simply equals to their x components will multiply with each other, it's 3 and 2 directly if you write them. Y components multiplied with each other, 4 into 3. Z components, which is 0 into 4. So it's 3 into 2 is 6 plus 4 into 3 is 12. 4 into 0 is 0. So 12 into 6 is 8. 12 plus 6 is 18. So this is the final result. Okay, and yeah, this is how you do it. This is the dot product, and let's say if it contains x here, let's say, so it's 3x here then, because I had components 3x, so it's 3x into 2, which is 6x. So 6x plus 12 is the final result, because again in terms of variables the same rule follows, that only the same variables add up to each other, and you can see here this is the final result in that case. So yeah, I hope you understood the method, and you must be wondering that how this thing is originated. This is really simple. Okay, if we talk about the unit vectors here, unit vectors are simply the vectors who have the magnitude equal to 1, but they just show the direction. So we have these three unit vectors. These are perpendicular to each other. It means the angle between them is 90 degree. Okay. Now what if we want to calculate the dot product between these ones? So if we have I hat dot I hat, what will be the result? So magnitude of first vector, magnitude of I hat into magnitude of the second vector, which is I hat again, cos of angle between them, which is angle between them is 0 degree because they are similar vectors. Same vectors have 0 degree angle between each other because they are parallel, because they are similar. And you know about vectors that two vectors will be same if their magnitude as well as their direction is same. So direction same means they are parallel to each other, which means the angle between them is 0 degree. And magnitude of I hat vector is 1 by definition, since it is a unit vector. Unit vector has magnitude equals to 1. Cos of 0, what is cos of 0? This cos of 0 is 1. So the result you get is 1. Okay. Similarly for j hat dot j hat, k hat dot k hat equals I hat dot I hat, you'll I hat, they are all equal to 1. This is one thing. The second thing that comes here is about cross product. No. We are not talking about cross product here. Let's find out. This was one of the result that you need to remember, that this is the self product. You can say the self product. This is the self product, that means product of a vector with itself. Now let's find out the product of I hat with j hat. What does it results? So magnitude of I, which is 1, magnitude of j, which is 1 again, so I'm not writing it again. Cos of angle between them. Now I and j are perpendicular to each other, so the angle between them is 90 degree, and cos of 90 is equals to 1. Cos of 90 is equals to 0. So 1 multiplied by 0, which results 0. Let me use brackets here so that you may not confuse with dot and cross product type of thing. So it's 0. So it means I hat dot j hat is equals to 0. Similarly, you can prove it easily that their product with each other is equals to 0 because they are perpendicular to each other, and perpendicular vectors have their dot product equal to 0. So that is how it works. And now let's move to that multiplication thing. We can very easily prove that resultant formula that I wrote for you people to calculate the dot product by the conventional method of multiplication. It's bx I hat plus by j hat plus bz k hat. It's simply like you will multiply ax with all of these quantities with dot in between them, plus ay with all of these quantities with dot in between them, plus this one with all, and you will see when I hat will multiply with I hat dot product, it will result 1. But when you will multiply ax I hat dot by j hat, I hat dot j hat will result into a 0 quantity. That is why ax by and ax bz become 0, and they will not appear in the final result. Only the ones which have the same unit vectors will survive. Okay, for this reason, let me write it. You will multiply ax I hat with all of these, so it's ax I hat dot sign with bx I hat, then plus sign ax I hat, the same way as we multiply in normal algebra. Ax I hat dot by j hat plus ax I hat dot bz k hat. Then we have this quantity, it will be multiplied with all of these. You write the similar thing for all them. Then az multiply with all of them, you write similar thing. I'm just justifying here the final result that I quoted before. So you will see ax, bx are simply scalars, so they will come outside. I hat dot I hat is the main vector here. So vectors will decide what will be the final result. So I hat dot I hat will result into 1. That is why it remains here with ax bx plus sign. Then we have ax by, they will come outside. I hat dot j hat, we know that I hat dot j hat is equal to 0. That is why it will result into 0. Then I hat dot k hat, it will result into 0 quantity again. That is how they all will result into 0. Just the ones with similar unit vectors will remain, and that is why ax bx remains plus ay by remains plus az bz remains. I hope you got what I'm saying. Okay, so yeah, that is how it works, and this is how you calculate scalar product. There are these two basic ways to calculate them, and I hope you got everything about scalar products and you are good to go now. So yes, you can find out if you know the vectors. Okay, you can find out their magnitude by simple formula, this simple formula. Oh sorry, it's, if you want to find out magnitude of a, it's ax square plus ay square plus az square. Okay, similarly for b you can use the similar formula, like bx square plus by square plus bz square with under root over it. This gives the b magnitude. And if you want to find out the angle between a and b, how you can do that? It's like a dot b, okay, divided by ab, which is equals to cos of theta. You will find out the angle by taking cos inverse at the end of this quantity. Here a dot b will be calculated by multiplying the respective components with each other, just the way I mentioned before, like ax bx plus ay by plus az bz, okay, divided by a and b are known by these things. You write them here, okay, and cos inverse of this thing will give you the theta angle. I hope you get it. Okay, so there are many ways to manipulate different things to calculate the one that we want to calculate. Yeah.
Goodbye.